Perfectly fine. Good, good. Okay, okay. Before I start today's marathon, let me introduce myself quickly. I am Satya, research scholar with 15 plus years of teaching experience, mentored more than 35,000 students, qualified in GATE, UGC NET, qualified in SET, and also certified by Cisco. My areas of expertise include programming data structures, algorithms, computer networks, computer organization and architecture, and operating systems. Okay, guys, Mr. Dheeraj Sardana sir, who has pursued his MTech from NIT Bhopal with 11 plus years of teaching experience, will come live on 10th January 7:30 p.m. and will give the tips and tricks guide 2024 GATE aspirants on how to ace GATE with college as well as job. So how to balance these two? On this topic, Dheeraj Sardana sir will give tips and tricks. So if you have any friends who is preparing for 2024, any friends or any colleagues, please do share this session information because it would be useful for them. Okay. Now guys, BYJU'S Exam Prep Mega Mock Challenge, All India Open Mega Mock Test will be live from 10th Jan to 16th Jan. At this time for 2023 aspirants, these full length mock tests are very important. So 10th Jan to 16th Jan, a mega mock challenge will be live. Whenever you get time, I can say, please find some time to take this mega mock test because it would be very, very useful. Okay. So guys, from this computer organization and architecture, the syllabus given by IIT body, the official GATE syllabus of this subject include measure instructions, instruction formats, addressing modes, main memory design, ALU data path, control unit design, secondary memory, cache memory, instruction pipelining, and IO interfacing. These are what different topics we have in COA, right? Then in today's marathon, what we are going to practice on what topics? Today marathon, we will be practicing these 6 topics: measure instructions, instruction formats, addressing modes, ALU data path and CU design, and finally IO interfacing. And tomorrow we will practice the rest of the topics: main memory design, secondary memory, cache memory, instruction pipeline. Okay? And tomorrow the session is in the morning 10 o'clock. I think you all know it. Fine. So to attend this marathon, let me give some guidelines. As usual, today we will be practicing a total of 40 questions. Each question is given sufficient time as per the difficulty level of the question. And understand, as and when I display the question, your time starts. And whenever you are giving the answer, please use question number with the answer. And please try to solve every solution, every question solution, especially numerical question, on the paper, not in the air. Please make it as a habit so that your accuracy improves, speed also improves. And please maintain a comment log for wrong answers so that you can identify your mistakes, where you are weak at, so that you can improve later. Okay? So guys, I wish you all the very best for these upcoming 40 questions. Are we good to go? Are we good to go? Everybody please respond. Hello Rai. Are we good to go? Whoever watching it live, please mark your presence. Let me know your names. Aryan, Rai, and whoever are watching, please mark your presence in the chat box. Please type go, everybody. Hello Bruce, Anuja. Everybody else, please type some message in the chat box so that I know whoever are watching it. Chalo, let's start today's marathon. Today's 40 questions we are going to practice. Let us start with the question number 1 from the topic machine instructions. First we are going to practice this topic, okay? Machine instructions. Okay Archana, chalo. Here is the first question guys. Consider the program segment below with initial values at 1000, 2000 and 3000 memory locations as 10, 20 and 30 respectively. Okay. After the program execution, the value at 3000 memory location would be. Come on guys, solve it. I'll give sufficient time, don't worry. Solve it quickly and attach the question number while you are giving your answer, okay? Try to solve at the earliest. Try to solve at the earliest. Okay, Aryan is giving option A. What about others? Okay guys, let us solve. We are given at 1000 memory location. Wait, let me change the color so that it is clearly visible for you. At 1000 location, we have 10, at 2000 location 20 and at 3000 location 30. Okay. Now let us run the program. Add 1000 comma 2000. What it will do? It will add values at 1000 and 2000 and place the result back at 1000. This is the meaning of it. When nothing is mentioned, you can take this format. So 10 and 20 added, 30 stored in 1000. Then sub 3000 comma 2000. That means at memory location 3000, the value at 3000 and value at 2000 are subtracted. So that 30 minus 20, 10 would be stored at 3000. Mul I 3000 comma 20. See, when there is a prefix suffix I, this is indicating immediate operand. Numbers are values, but to differentiate, to indicate assembler that this is not value, this is address, the 3000 is kept in the parenthesis. So its meaning is at memory location 3000, memory location value at 3000 should be multiplied with value 20. That means 10 into 20 multiplied, result stored back in 3000. Now div 3000 comma 2000. So what this means? Value at 3000 should be value at 3000 divided by value at 2000. That is 200 divided by 20, which is 10, stored back in 3000. So after the execution, the value at 3000 memory location is what? 10. The answer is option A. Correct. Very good, Aryan. Very good, Saubhagya Nayak. Okay. Let's proceed to question number 2. Consider the instructions and their respective sizes in words as below. Let the word length is 4 bytes. If all instructions are stored in serial manner starting from the address 5000, then the absolute difference of I3 address while word addressable and byte addressable memory configurations is. Quickly solve it. Don't take more than 1 minute time, because this deserves just 1 minute time. Second question answer, please. Archana, Bruce, Anuja, Efrai, you got the first question. Solution, you understood? Okay. Okay. So Saubhagya says second question answer is 9. All right. We are given 5 instructions: I1, I2, I3, I4, I5, and the size in words is 4 words, 8 words, 2 words, 6 words, 2 words. Word addresses would be 5000 to 5003, 5004 to 5011, 5012 and 13, 5014 to 19, 5020 to 21. And what is the size in bytes? One word is given 4 bytes. So 4 words would be 16 bytes, 8 words would be 32, 2 words would be 8, 24, 8. Now byte addresses, in the byte addressable configuration, if we derive the addresses, it would be 5000 to 5015, 5016 to 47, 5048 to 55, 5056 to 71, right? 56 4, 79, 5080 to 87. Now I3 address, word addressable configuration address is 5012, byte addressable address is 5048, right? So the absolute difference would be equal to 5012 minus 5048, that is 36. Hence the answer should be 36. Okay, Saubhagya Nayak, sorry, I will accept, but system won't accept. Be careful. प्रोग्रामिंग वाला आपका नाम क्या है? सबको ये सॉल्यूशन क्लियर है? चलो तीसरा सवाल को जाएंगे. क्वेश्चन नंबर 3. Assume that program segment has 4 instructions I1 to I4. Size of instruction I is double that of instruction I minus 1, while size of I1 is 1 word. Let word length is 32 bits. The address of I3 with byte addressable memory if the program started from 5000 is. All numbers are in decimal. Quickly solve it. Aryan says C. Very good. Good Aryan, you are quick enough. Maintain the same speed, but make sure the accuracy. Saubhagya, Bruce, option C. Okay. All right. We are given 4 instructions. First instruction size is 1 word. Other instruction size is double that of previous instruction. I size is double that of I minus 1. So I2 size would be 2 words. I3 would be 4 words. I4 would be 8 words. And as it is byte addressable, convert the size into bytes. Given 1 word equal to 32 bits means 4 bytes. So 4 bytes, 8, 16, 32. Now I3 address we want starting from 5000 byte addressable. So for size of bytes we will give the address 5012. Okay. So I3 address would be, starting address is what considered as address always. So it is 5012. Good. Saubhagya Nayak, dear friends, everyone, congratulate Saubhagya Nayak. He got selected for DRDO. He shortlisted. He has interview, definitely he will do well and he become DRDO scientist soon. Okay, chalo. The answer for question number 3 is 5012. Question number 4. Let the program has 10 instructions I1 to I10 to execute. The size of first even instruction is 1 word and the size of last odd instruction is 128 words. Each word size is 32 bits. The size of other instructions is twice that of previous even instruction. If it is even, half of next odd instruction if it is odd. The size of instruction I5 would be dash bytes. सौभाग्य नायक, वंस यू सेलेक्ट फॉर DRDO, हमको एक इंटरव्यू चाहिए आपका, मंजूर है? साइंटिस्ट साहब, what is the answer for this question number 4? Thank you, Saubhagya. The pleasure is always mine. 32. Okay. Ashwati, good evening. We missed you yesterday. I am good, Ashwati. How was your trip? I hope all well. Chalo, focus in the session. We have instructions I1, I2, I3, I4, I5, I6, I7, I8, I9 and I10. The first even instruction size is 1 word. What is the first even instruction? I2. So it is 1 word. And the last odd instruction size is 128 word. Last odd instruction is I9. The other instructions size is given as twice that of previous even instruction if it is even. That means I4 size would be twice that of I2, I6 size would be twice that of I4, I8 size would be twice that of I6 and I10 size would be twice that of I8, 16 words. And size of odd instruction size is, if it is odd, its size is half of next odd instruction. That means if I1 size you want to know, I3 size should be known, I3 size I5, I5 size depends on I7, I7 size is half of I9, so it is 64, I5 32, I3 16, I1 8. This is how it is. We want I5 instruction size. So I5 size is 32 words. The answer is not 32 Bruce. We are given one word is equal to 4 bytes. So 32 words means 32 into 4, 128 bytes. Hence the answer should be 128. Bruce, please be careful. Please be focused. You know the answer, but you did not read the question properly. Hence, you have given the wrong one. Unnecessarily, you lost mark. Similar mistakes I don't want you people to do in the actual GATE exam. So, this is just like rehearsals for you, mock for you. Okay? Everyone, be careful. Bruce, please mark yourself wrong and write that comment. Did not read the question properly. Okay? Chalo. Question number 5. Before that, am I clear with the solution of this question? Everybody? Ashwati, Saubhagya, Bruce, Prasenjit, Aryan, Programming Wala, Archana. Are we clear? Efrai? Are we clear with the solution? Prasenjit, why you are not giving any answer? Why you are silent, Prasenjit? Archana, are you there? Ashwati? Come on, keep involving in the session. Okay? Let's proceed to question number 5. Match the following. Opcode type. We have opcodes are CMP, COM, BUN, CIR. Type bitwise, logical, control, shift. Match quickly. Guys, it's a IIT conducting GATE exam, right? So, we can't take a chance. We can't say that this is not possible, that is not possible 100%. From any small topic, question बना सकते ये लोग IIT professors. So, we have to be ready from all the dimensions. 360-degree preparation we have to do. Aryan says D, Saubhagya Nayak says D. Okay, okay. Prasenjit D. Ashwati, others. CMP, compare. COM, complement. BUN, branch unconditionally. CIR, circulate right. Means circular right shift. Okay. Complement is bitwise instruction. BUN is control instruction. Circular right shift instruction. Compare is logical. So, A2, B1, C3, D4, yes. Option D is the right answer. Hello Deepak Prasad. Hello Programming Wala. Programming Wala, I was asking your name. What's your name, if you don't mind? Okay, good. Keep it up. Question number 6. Consider a processor executing the following program segment R1, R2, R3 program segment, okay. R1, R2, R3 be general purpose registers. If the program has been loaded starting from address 2000 in word addressable memory, then the return address pushed on the stack is dash. Consider interrupt occurred during INC instruction execution. Very easy, very easy. Okay, Dhruv, good name. Thank you all. I would like to say thank you all. You were constantly attending all the sessions of mine and other. Definitely you deserve a success. So please try to materialize your hard work. Focus for this rest 20 days, guys. Rest 20 days. GATE should be your priority. Okay. Come on, guys. It's a very easy question, but it's recurring model question. It's a recurring model question. When we derive the addresses, word addresses only we want. So no need to convert. However, word size is not given. Starting from 2000, so 2000, 2001 for the first instruction, 2002 to 2005 for the next, 2006 to 2009 for the third instruction, 2010 to 2017 for the next, 2018 to 2019 for halt. Here, interrupt occurred during INC. When interrupt occurred for non-halt instructions, the next instruction address is pushed on to the stack. This address is pushed on to the stack because after completing the current instruction execution, ISR is serviced, right? So the PC value is pushed on to the stack. So what would be pushed? 2010. Okay. Good. Dhruv, Aryan, Saubhagya Nayak, very good. Prasenjit, Deepak and everyone, got it? And guys, for your info, today there is no break because today questions are little simple questions, simple but significant questions. So probably we can close the session around 3 hours of time, 40 questions. So today I am not going to give any break. Okay, be prepared. Question number 7. Read the question properly and give your answer. For the same instructions, if interrupt occurred during halt instruction, what is the return address? The return address pushed on to the stack is dash. (2018) is what the starting address of halt. Quick. Two 2144. अच्छा, guys, interrupt occurred during halt. Halt indicates no further execution. So after executing halt, nothing can be done by the system, because halt indicates turn off, shut down, keep quiet, don't do anything. So how the interrupt request can be serviced if halt is executed? Halt executed means going down. So while halt when interrupt occur, same instruction address is pushed onto the stack. You need no need to write all the addresses, just calculate before halt total how many words are there. 8 plus 8, 16 plus 2, 18 words, all these instructions size. Given it is byte addressable memory. Byte addressable memory. So just convert these 18 into 8. So total 144 bytes. Right? So starting from 2000, it would be 2143. So what would be halt instruction starting address? 2144. Dhruv, you got 96. Check once beta. If you want, I can write complete addresses. In size, if I write in bytes, (16, 32, 32, 64, 16). This is what the size in bytes. So byte addresses would be 2000 to 2015, 2016 to 47, 48 to 79, 80 to 143, 144 to 159. So it would be 2144. Okay. Question number 8. Assume that certain processor executing the following instructions. Let the size of these instructions is 1, 2, 4 and 6 words respectively. The number of clock cycles for each operation be as follows. Fetch 2 cycles, decode 4 cycles, memory to register transfer 4 cycles, register to memory transfer 8 cycles, arithmetic operation 3 cycles. The total clock cycles required to execute the program would be, how many clock cycles are required to execute the program? Means all phases together. Fetch, decode, execution together. Quick. 70 clock cycles. Okay. Instruction size given: one word, two words, four words, six words. Now, if you just see this, we require fetch, decode and execution phases here majorly, because operand fetch or register read or write back not given specifically but given in other way. Given fetch require 2 cycles, 2 clock cycles. How much can be fetched at a time? One word can be fetched at a time, guys. Always remember, memory can transfer how much at a time to CPU? One word at a time. Why? Whatever gets transferred from memory, CPU keep in the register. That register capacity is what said to be one word. So, for one word, 2 cycles. For 2 words, 4 cycles. For 4 words, 8 cycles. For 6 words, 12 cycles. Plus, decode is done by control unit. So, this won't be per word basis because it is not transfer, it is analyzing. So, we can say for decode 4 clock cycles. Now, execution. Execution means what? Performing the operation. Performing the operation, right? What is the operation to be done here? Add. Arithmetic operation require 3 cycles. What operation to be done in this second instruction? Move. From where to where? Memory to register. So, memory to register transfer require 4 clock cycles per word. How much data is there? How much data is there in this 5000 address location? We don't know. But per word given means we know only one word can be transferred at a time. That is coming to R3. So, we can say 4 clock cycles. And what is this store? R3 to 2000, register to memory transfer, that require 8 cycles, and sub arithmetic operation 3 cycles. So, total is 2 plus 4, 6 plus 3, 9. 4 plus 4, 8 plus 4, 12. 8 plus 4, 12 plus 8, 20. 12 plus 4, 16 plus 3, 19. So, what is the total? 12 plus 9, 21 plus 20. 41 plus 19, 60. So, the answer is 60 clock cycles. Got it? Aryan, Saubhagya, Decode part, decoding is done by control unit. Means analyzing what to do, what is the source operand, what is the destination operand, what is the opcode, in which mode the operands are represented. This analysis is what decoder do, control unit to do. That is what we say decoding. That is independent of the instruction size. So, that is uniform for all the instructions. Okay? Am I clear, everyone? Chalo. Question number 9 on your screen. Consider the steps for fetching an instruction below. Consider PC is incremented implicitly. Which of the following is the correct sequence for fetching an instruction? At third instruction execution, see, wait a minute guys, Saubhagya Nayak, which one you are talking about? Store 2000 comma R3. Okay, see, this is the instruction size. We are storing the operand from register to memory. We are transferring operand R3 value from register to memory. We are not transferring this instruction, no? So, why we count instruction size here? Okay? Don't confuse. For instruction size, I have already taken here. As I am transferring the instruction from memory to CPU, I have taken their size already. Okay? Chalo. Question number 9. Identify the correct sequence for fetching the instruction. Quick. Yes, please. Saubhagya Nayak says option C. Chalo. Instruction fetch means what are the steps that happen? From which address to fetch the instruction, that is known to PC. That address copied to MAR. Then PC should be incremented. Then read command, so that at this address whatever is available, where it gets copied, not to IR directly. IR don't have bus connection to the memory. MDR. From MDR, we again have to shift to IR. Okay. So these are the 4 phases. Here PC increment happens implicitly. So we need not to consider this. So when this PC to MAR can happen, PC read, MAR write. So definitely PC read, MAR write should happen first. So S3, S4 should be first. Okay. Now what is the next phase? PC is incremented implicitly, so let us neglect. You have to read the instruction from memory, then that is copied into data register. But from at which address how memory knows? At which address how memory knows? Memory should be taking the address from MAR. So read MAR. Who is reading? Memory is reading. Read content from that address. Write in the MDR. So this should happen first. Then read MAR, read from memory, write in the MDR. But what you fetched? Instruction. It is supposed to be in the instruction register. So shift it to instruction register. MDR read, IR write. So read MDR, this should be later, write IR, this should be later. So this is the sequence. So S3, S4, S1, S5, S7, S6, option D is the right answer. Clear? Are we clear? Let's proceed to question number 10. A CPU has only 5 byte instruction. A program starting address is 104. Find the correct legal program counter value in between the addresses 201 to 205. Very easy. Correct legal program counter value. Yep. See, 201 minus 104 divided by 5. You should get integer. It is not integer. 202 minus 104 by 5, not integer. 203 minus 105 by 5, not integer. 204 minus 104 by 5, yes, it is 100 by 5, that is 20. So it is integer, means whole number. 205 minus 104 by 5. It is also not integer. So what is the correct legal program counter value? It should be multiple of 5 from 104. Isn't it? But please understand one thing. You are starting from address 104, 104 to 109, 104 to 108, 109 to 113, 114 to 118, 119 to 123. In this way it goes on. If anyone is having the doubt, sir, we are starting from 104 means it should be 203. No, this is what the proof. You have exactly 5 difference. So in this way you will get 204 only as the starting address. Okay? Have no doubt. Answer is 204 only. Good. Now you can download our GATE and ESE. Aspirants, you can download the test series that strengthen your practice with 4000 plus practice questions completely, that include 40 plus full length mock tests and 30 plus subject wise and part tests with virtual calculator with detailed mock analysis. So avail the test series by visiting our BEP app or website. Okay. Now let us proceed to instruction formats. So guys, machine instructions part. Now you feel confident. You learned something if you don't know, or you have revised machine instructions part. I tried to keep all different possible model questions. Please respond. Okay. Chalo. Let us extend our practice on instruction formats. Okay. Here is the first question, means question number 11. A computer has 32-bit instructions and 12-bit addresses. If there are 252 address instructions, how many one address instructions can be formulated? फटाफट करो सब लोग. What is the answer for question number 11, dear friends? $24,576. अच्छा, okay. We have 32-bit instruction. We always give priority for the larger sized instructions. 2 address, 1 address we have. So, first we give the priority for 2 address. So, we have 2 operands. Given 12-bit addresses it use. So, 12 bits for each operand. So, 12 plus 12, 24 gone for the operands. So, we have more 8 bits for the opcode. Now, with 8 bits, total how many opcodes are possible? With 8 bits, total opcodes possible are 2 power 8, 256. 256 opcodes are possible. But given 250 2 address instructions are there. That means for 1 address instructions 6 opcodes are left. So, we have 6 opcodes with 1 operand. Only 6 opcodes, but this operand can vary in 2 power 12 ways. So, total 1 address instructions possibility would be 6 into 2 power 12, 6 into 4096, 24576. Okay? Am I clear? Chalo. Let's proceed to question number 12. A system has 16 bits instruction that supports 0 address, 1 address and 2 address instructions. Assume each address field size is 5 bits. It is designed for supporting 40 number of 2 address instructions, 400 number of 1 address instructions. The maximum number of 0 address instructions that can be formulated is. Quickly solve. $11,776. Okay. What about Aryan Kaur, Prasenjit, Deepak, Ashwati, given the system supports 0 address, 1 address, 2 address. So, first allocation will be done for 2 address, remaining 1 address, then 0 address. That is how the design would be. We know to address instruction means opcode is mandatory with 2 operand fields. Every address field size is 5 bits. Total instruction size is 16 bits. So 6 bits left for the opcode. Six bits left for the opcode. Now, with 6 bits, 2 power 6, 64 opcodes possible. In that, given we have just 40 to address instructions. So, in this 40 only to address instructions are there. So, for one address and 0 address, remaining opcodes would be 24. In this, again, first we give priority for one address. We can have 24 into 2 power 5, 24 into 32 total one address instructions possible. What is that value? 24 into 32. 768 possible. But given only 400 are there, 400 number of one address instructions possible there. So, remaining for 0 address would be 768 minus 400, 368. These 368 can have value, 5-bit value in 2 power 5 combinations, means 0 to 31, any combination it can have. So, 368 into 32, that is 11776 total 0 address instructions are possible. Got it? Yes, you are correct, Saubhagya Prasenjit. Very good. Okay. Let's proceed to next question. Question number 13 on your screen. Choose the correct statement or statements from below. It's a very simple question, but possible. This kind of questions are also possible. It's a MSQ question, guys. Choose the correct statement or statements. CISC supports only register operands. False. It supports memory operands, register operands, IO operands. All kind of operands CISC supports. CISC supports fixed length format. If it supports fixed length, why do we get 3 address, 2 address, 1 address variabilities? So, no, it is false. RISC supports variable length instruction format. No, RISC supports fixed length format. Register operands only. For load store instructions, all it follow register organization it use. So RISC supports only register operands. That is only true. Okay. Question number 14. Match the following. Instruction is left side. The format of instruction on the right side. Match both. B. Okay. See, we have register operands, 3 operands. So actually it can be 3 address also, but let us see. We have 2 address, so it is a 2 address format. 1 address, 3 address. So here it is, as RISC supports only register operands, we can relate to this. So 1D, 2B, 3C, 4A, option B. Correct. Question number 15. A processor has 80 distinct instructions and 50 general purpose registers. A 32-bit instruction word has opcode, 2 register operands and an immediate operand. The number of bits available for the immediate operand field is. Very popular model question this is. $13. All right. We have 32-bit instruction word. That means instruction length is 32 bits. We know instruction for sure will have opcode. That need not to be given because opcode is by default. Along with opcode, 2 register operands and an immediate operand. Let it be X. We have 50 general purpose registers. There are 50 registers. That means each register is represented with log 50 base 2 seal value number of bits. That would be 6 bits. Now, opcode means how many opcodes we have. Accordingly, you can find the number of bits. We are given 80 distinct instructions. Means instruction to instruction. What could be the difference? One possibility is 80 distinct opcodes. That means each opcode can have log 80 base 2 seal value number of bits. That is 7 bits. So out of 32, 7 plus 6, 13 plus 6, 19 bits gone. So how many bits available for the immediate operand field? 13 bits. So answer is 30. Good. Question number 16. Consider a processor with 32 registers and an instruction set of size 12. Each instruction has 5 distinct fields: opcode, 2 source register identifiers, 1 destination register identifier, and a 14-bit immediate value. Each instruction must be stored in the memory in a byte aligned fashion. In a byte aligned fashion. Then if program has 200 instructions, the amount of memory in bytes is okay. Saubhagya Nayak logged it. Saubhagya Nayak. Chalo. Given every instruction has opcode, 1 destination register identifier, 2 source register identifiers, and a 14-bit immediate value. We have 32 registers. So each register is represented with log 32 base 2 seal value bits, that is 5 bits. So 5, 5, 5. And we are given instruction set size is 12. So opcode will have log 12 base 2 seal value 4 bits. This is 14 bits. So total instruction length is 14 plus 15, 29 plus 4, 33 bits, right? bits. But it is given the instructions are stored in byte aligned fashion, means complete byte or none. So actually 4 bytes not sufficient. Due to byte aligned, 5 bytes would be given. 5 bytes per instruction allocated. So total program is allocated with 200 into 5, 1000 bytes of memory. But in that 1000, all are not utilized. We want wastage. Wastage we want. For every instruction, how many bits are getting wasted? 7 bits are getting wasted. So 1400 bits is the wastage, but I want in bytes. So that is 1400 divided by 8. 8 ones are 8, 8 sevens are 56, 8 fives are 40. So 175 bytes is what the wastage. So that is what we want. Okay? Am I clear? Chal. Question number 17. Consider the following program segment. Here R1, R2, R3 are general purpose registers. Assume that content of memory location 300 is 8 and content of register R3 is 200. Content of each of the memory locations from 200 to 208 is 10. The program is loaded from the memory location 1000. All the numbers are in decimal. Assume that memory is word addressable. The number of memory references for execution cycle of the above program is. What is the answer? We are given the content of memory location 300 is 8. Register R3 is 200. Each of the memory locations from 200 to 208 is 10. Program loaded from location 1000. Okay. If the memory is word addressable, how many memory references for the execution cycle? Means only for the EX phase, how many memory references are needed? We have to find out. First instruction executed. What is the first instruction? Move R1 comma 300. So 300 content is loaded into R1. 300 is the address. What is there? 8. So R1 will have 8. For this one, memory reference is needed. And loop, move R2 comma R3. R3 in parenthesis means the value at 2000 to R2. Value at 200 to R2. What is value at 200? 10 to R2. So R2 will get 10. Add R2 comma R1. So R2 will have 18. 10 plus 8, 18. Move that value back to that location. So here you will have 18. Increment R3. R3 becomes 201. Decrement R1. R1 becomes 7. BNZ means branch if not 0. If not 0. Which not 0? Accumulator value not 0. What accumulator will have? The recently performed instructions result means R1's result. That means until R1 becomes 0, this loops. So from that we can understand these instructions execute 8 times. Right? Because from 8 to 1, 8 times it executes. In this instruction and this instruction are the memory referring instructions. So this first instruction executes, move R2 comma R3 executes 8 times. And this second instruction also executes 8 times. All the other instructions just using registers, so they don't need any memory reference. Hence, total memory references are, this is 1, this is 8, this is 8, 17. Memory references. Aryan, R3 is register, that is in the CPU. So accessing R3 don't need memory reference. When you access R3, you got 201. Then you visit memory. So that is one reference only. That is instruction size. Saubhagya Nayak, again you are confusing. That is instruction size. It is not the operand size. We are not moving instruction to R1. We are moving value at 300 to R1. Don't confuse. Please make a note of this. You are getting confused in this point very much. Okay. So, question number 17, answer is 17. Clear? Next question. Question number 18, everything same. The number of memory references for complete execution means all the phases, not only execution phase. For all the phases, total how many memory references? It's the same data. Instruction fetch, memory reference is needed. Decode, no memory reference. Operand fetch, memory reference needed. And memory write back or execution, if it is a move kind of operation, for such execution means transfer only, right? So please understand that. So instruction fetch, two words means two references, and all these instructions execute 8 times. Just now we have seen. Hi Tushar, good evening. So every time this should be loaded. So every time memory should be referred, isn't it? So 1 into 8, 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 2 into 8. Plus the first instruction should fetch the operand from memory. So that require one memory reference. But how many times it fetch? 8 times. The next instruction, move R3 in parenthesis comma R2. It is storing the value back in the memory. So that is taking again one memory reference. Sorry, here I have to add. Okay. And the first instruction, fetch the operand one time, that executes one time. So one memory reference. So all together total how many memory references? This is 2, 8, 8, 8, 8. Okay, we have one more instruction, halt, wait. 8, 16. Now halt instruction should be fetched once and it won't require any other memory reference. But it should be fetched from memory only. It is executed only once. So this is total 1. So all together this is 8 plus 2, 10 plus 8, 18, 26, 34, 42, 16, 58, 59 plus 9 plus 8, that is 17 plus 59, 76. So total memory references 76. Clear? Okay. Question number 19. This is already solved, right? This we have already solved, right? Sorry. So that is by mistake it is there. So this is the question number 19. Wait a minute. So now we are moving on to addressing modes topic. Yes. Consider the addressing modes and their applications given below. Which of the following pairs are valid? Which are valid pairs? Yes. 19th. Which are valid? ACC. Okay. What about Aryan and others? Relative addressing. Vector implementation. What is vector means? Array. 1D array is what? Vector. So array implementation, what addressing mode we use? Indexed addressing mode. Indexed addressing mode is also called as scaled addressing mode. So this is correct. This is wrong. Based addressing is used for program relocation. Yes. Keeping the base register and offset, program can be relocated at runtime. Based addressing is used for program sequencing. What next? What next? No. No. Relative addressing is used for program sequencing. Program counter we use. So the right answer is B and C. Okay. Tushar, check that again. Check it again. There is one. For the first instruction, one is there, that I think you forgot. Okay. Chalo. Question number 20. In the register indirect addressing mode, operand is inside the instruction, address of operand is inside the instruction, register containing operand is inside the instruction, register containing address of operand is inside the instruction. In the register indirect addressing mode, yes, the register containing address of operand is inside the instruction. Suppose if I write something like this, move R1 comma R3. Suppose R3 is having some 2000 address. At 2000 address we are having the value. This is what we say register indirect for source operand. Source operand is what always taken for addressing mode measurement. Okay. Question number 21. Match the following. Match the following. Absolute addressing, scaled addressing, auto increment addressing. Yep. Absolute addressing is what also called as direct addressing. So, operand is the effective address. Scaled addressing is also called as indexed addressing. So, the effective address is at an offset, at an index. Auto increment addressing is what the next address to the given. Yes. So, 1B, 2A, 3C. Correct. Clear? Question number 22. The number of memory accesses required for each operand in memory indirect addressing mode is exactly 1, exactly 2, at least 2, at most 2. Yes, it is minimum 2, at least 2, at least 2. Suppose if I give some address like this, add R1 comma something like this. 2000 is having, let's say, 4000 address. 4000 is having, let's say, 4024. 4024 is having the value. How many times we are referring the memory? 3 references. Just I am giving an example. But minimum 2 required. based on the number of indirections it can extend. Okay. Next question. Total number of memory accesses required to complete the following instructions execution is. Suppose every instruction is one word long as well as every address. Means every word. Saubhagya Naik 3. Okay. First of all, for instruction fetch, we require 111 memory reference because every instruction is of one word. And while execution or operand fetch, you say it requires 0 operand, 0 memory references because operands are register operands. It require 1 memory reference and it require 2 memory references because it is //R3 given. So it is something like R3 has 1000, 1000 is having 2000, 2000 is having value. So for register reference, we don't count it as memory reference. So here one time, here one time. So 2 memory references. So total 3 plus 3, 6 memory references are required. Tushar, Saubhagya Naik, total 6 memory references are required. Okay. For execution cycle 3, no break today. For execution cycle 3, execution no. See, here execution means doing addition. For addition, memory reference is not needed, and for storing the result, we are storing all the way, you are storing in R1 in the register. Okay, Saubhagya Naik. Execution means doing the operation specified by the opcode. That is what execution means. So for move, load, store, execution means fetching or writing back. Not for these arithmetic operations. Arithmetic operations execution means addition. Okay. So here only instruction fetch, operand fetch require memory accesses. Fine. Question number 24. How is the effective address is calculated in scaled addressing mode for instruction? Opcode destination operand, source operand. Let destination operand be R1, source operand be A1. So how do you calculate the effective address in the scaled addressing mode? Okay. Scaled addressing means indexed addressing. If you know the other name of scaled addressing, it is just very damn easy. If you don't know, if you think scaled addressing means some other mode like relative mode or implied mode or something else, then there is a chance for giving the wrong answer for this. Right? Just think, as you know scaled means indexed now, you can directly say yes, A1 plus index register value is what? Scaled mode. How many of you known that scaled addressing is called indexed addressing in today's class? Are there anybody? Because I know some students don't know this name. Indexed mode name is a scaled mode. That's why I am asking. Anybody who learned this term today? See, Prasenjit. Like this, there can be many students, right? And in that 3 hours pressure, while you write the GATE exam, your mind would be under so much pressure. In that pressure, that should get striked also, though you know. So there is a possibility of lot of confusion. That is what make the professors to prepare such questions. As you know that scaled is indexed, now it is easy for you, but don't think this much easy question is possible in the GATE. Than this, even more easy questions are also appeared in GATE. So why not this? I think you understood. Yep. Question number 25. In the instruction move A, #55H addressing mode, addressing mode used for operand #55H is. What is the addressing mode used for this #55H? Yep. Hash indicates immediate. Please remember. @ is for indirect. Okay, please remember these two, may be helpful. So hash, as it is preceded by, it is indicating the value. Immediate means it's a value, direct value. Okay. Question number 26. Match the pairs in the following: base addressing, indexed addressing, stack addressing, implied addressing. Hmm. 26th question answer. Base addressing is for, stack addressing is used for reentrancy. Reentrancy means while you are executing some function, the control transferred to another function, let's say from here I1, I2, I3, I4, I5. From I3 control went to F2 function. So this is what we call as re-entrancy. While interrupts, while this kind of procedure, indirect procedures calls, it is possible. It is called re-entrancy. What we do? The return address is pushed on the stack. That's why we call it as stack addressing. Okay. So A4, B3, C1, D2, option C is the right answer. Saubhagya Nayak, don't be in hurry. Scientist, respected scientist. Chalo. Question number 27. Suppose that memory location 1000, 2000 and 3000 has content 2000, 30, 40 respectively. If an instruction add R, OP1, OP2 produce output as 70, then identify correct statements with regard to this. What is the right answer, guys? Question number 27, right answer please. C. Correct. Guys, hash means we know it is immediate operand. So, when the first operand is value 30, second operand is value 40, 30 plus 40, 70, yes. Yes, it can have. And it is MSQ. If the first operand is given 2000, second operand is given 3000. That means what is the value at 2000? 30. Value at 3000? 40. So this also gives value at 2000 plus value at 3000. That is nothing but 70 only. So yes, it is also possible. And second option, OP1 equal to @1000 means it's a indirect. That means value at 2000, that is 3000. Value at 1000 is 2000, value at 2000 is 30 plus @2000, value at 30 at that value. So that is some unknown value. So definitely this is giving value at 2000. Right? And OP1 equal to @1000, OP2 equal to 3000. OP1 equal to @1000. So OP1 will be, yes, just now we have seen 30. OP2, parenthesis means you can use for value at 3000. So OP2 is also equal to 40. So 30 plus 40, 70. Yes, A, C, D are correct. सौभाग्य नायक एंड एवरीवन, एक सीक्रेट बोलूं? सीक्रेट मतलब मैं तो बहुत बार बोला था, फिर भी बोलता हूं. Easy questions are only dangerous. Easy questions only will take your marks, will give you negative marks. So, tough question automatically mind will set right, focus. Easy question के लिए खुद focus रखना पड़ेगा. So, easy questions require more attention, more focus than difficult questions. समझ गए बात? तो ये आदत करो. ये मैराथन के द्वारा आप क्या आदत करना, कभी भी आप डायरेक्ट क्वेश्चन, सिंपल क्वेश्चन, इजी क्वेश्चन देखते हो ना, पहले आप just have a long breath, relax, don't get excited, or at least try to control your excitement. आराम से एक लॉन्ग ब्रीथ लेके तब आराम से पढ़ो, आराम से क्वेश्चन को पढ़ो, ऑप्शंस को पढ़ो, तब जवाब दो. ये आदत करो. ये एकदम एक गेट एग्जाम पे करते बोले तो नहीं होता बेटा. मैराथन्स में, मॉक टेस्ट में ये आदत करो. ठीक है? गुड. चलो, now guys, our favorite Rakesh sir will be coming with exclusive general aptitude session for you. In 15 hours you can just gain 15 marks of aptitude very soon, very soon. So the official, we know the date when it is, but officially Rakesh sir will announce that very soon, guys. Just in few days this general aptitude session is going to happen. So stay tuned, it will be revealed very soon. And this very powerful combo of two legend faculty, Rakesh sir and Ankit sir, is coming together for you guys live soon with non-stop maths marathon, that complete maths syllabus just in 2 days. So if you just attend this marathon, engineering mathematics, discrete mathematics revision is done. And this also happen very soon. So stay tuned and press that bell icon if you have not, so that you will get immediate notification. Okay, चलो आगे बढ़ते. Now you can download our free ebook for your GATE preparation, and also you can get notifications about our regular scholarship tests and pre-GATE workshop details as notification if you subscribe and press the bell icon. Do subscribe if you have not subscribed yet, and do register for these workshops and scholarship tests, and try to circulate this information. Let as many people benefit as possible through you. Even if one poor student get the 90% scholarship, means that all credit will be yours. Okay, forget about us. You understand, you are referring this scholarship test, and one poor student performed well, he got 80%, 90% scholarship, like 30,000 course he just got for 3,000 rupees. So all his blessings will be with you, right? Think in that way. Rest is up to you. Okay, fine, thank you. Let's proceed to next topic. So we are done with instructions, machine instructions, instruction formats, addressing modes. Now are you confident, or at least are you gaining the confidence? Are you getting that faith, hope? Yes, COA, machine instructions, instruction formats, addressing modes question, with a little preparation, with a little revision, I would be able to attempt in the GATE exam. Are you getting at least that hope? Please answer. Good. Good. Chalo, let's proceed to ALU data path CU design topic. Here is the question number 28. Consider a CPU with 5 different types of control signals to generate multiple times. Type 1 to type 5 and their count we have got. The total number of bits required in vertical and horizontal microprogramming respectively are. Saubhagya Nayak logged it. In horizontal, one control signal, one bit. So, in horizontal, the total number of bits required would be 20 plus 10 plus 15 plus 60 plus 30. So, altogether it is 135. But in vertical, log n base 2 seal value required for n control signals. So, this is log 20 base 2, that is 5. Similarly, for this log 10 base 2, that is 4. Similarly, log 15 base 2, 4. Log 60 base 2 seal values 6. For this 5. So, this would be sum is 5 plus 4, 9 plus 4, 13 plus 6, 19 plus 5, 24. Now, we want in the order of vertical and horizontal. Sometimes this also plays very important role. In hurry, if you go for horizontal vertical order, that is wrong. So, be careful, be focused. Read the question completely carefully. So, in vertical horizontal order I want. So, it is 24, 135. Yeah. Question number 29. A hardwired CPU uses 10 control signals S1 to S10 in various timestamps T1 to T5 to implement 4 instructions I1 to I4 as shown below. Which of the following expression represent the circuit for generating control signal S8? What's the answer for this? Question number 29. Okay, Saubhagya Nayak. See, mark where we have SE8 for these timestamps of instructions. I have for I3 at T2 and I1 at T5, and where else? I2 at T2. Anywhere else? No, that's it. So I can say SE8 is equal to I2 into T2 plus I3 into T2 plus I1 into T5. So I1 T5, I2 T2, I3 T2. So it is option C. Prasenjit, why I4 into T5, Prasenjit? हाँ, क्यों बेटा? It is definitely option C, not option D. Okay. Question number 30. Consider the following common data path of a CPU. The instruction add R0, R1, R2 has the register transfer interpretation R0 equal to R1 plus R2. The minimum number of clock cycles needed for execution cycle of this instruction is. Three. Okay. Chalo. Let us see. In the first clock cycle, R1 read or out I say, yes in I say. In the next clock cycle, R2 out, T in. Okay. Now, in the next clock cycle, S out, ALU in, S out, T out, ALU in I can say, and then actually you require one clock cycle or some clock cycles for this addition, but until unless that is known how many clock cycles ALU take to do the operation, you cannot actually take something for granted. So we assume ALU is at a rapid rate it will do the operation in the same clock cycle. Then ALU out, and it is directly sending to the through the bus, through the data path. So I can say R0 in. So the minimum number of clock cycles are 4 clock cycles. Okay. Clear? Question number 31. Consider the following data path of a CPU, means the same data path guys. The ALU bus and all the registers in the data path are of identical size. All operations including incrementation of the PC and GPRs are to be carried out in ALU. 2 clock cycles are needed for memory read operation. First one for loading address in the address register, and next for loading data from memory bus into the data register. The instruction call rn, sub is a 2-word instruction. Assuming that PC is incremented during the fetch cycle, its register transfer interpretation is given. The minimum number of CPU clock cycles needed during the execution cycle of this instruction is. Yes, please. Three. Okay. Given PC is incremented during fetch cycle, right? But incremented PC value is in PC only, not in RN, no? So, the first clock cycle PC out, RN in. That means this increment happened in the fetch, but incremented value is not placed in the RN in fetch. That was in the PC only. So now I am copying it in RN. And then memory operation require 2 cycles. T1, T2, this is for memory operation. What happens in this? Whatever acquired from the memory to load in the data register, isn't it? One for loading address in the address register, other take from memory and keep in the data register. But where you want? In the PC. You want it in the PC. So the next clock cycle that MDR out, PC in. So total how many clock cycles? Here also 4 clock cycles. Clear? Okay. Question number 32. Consider an instruction are not. Guys, let me hide myself. Is it needed? Do I need to hide myself or the diagram is visible? Is it visible or shall I hide? Give some response. Visible. Okay. Fine. So what is the answer? Consider an instruction. The following steps are used to execute it over the given data path. PC is incremented appropriately. Subscripts R and W indicate read and write operations respectively. Which of the above is the correct order of execution of the above steps? Guys, we have already solved 2 or 3 questions of this type. So I expect everybody to give the correct answer for this. Saubhagya Nayak, option D, logged. Don't retract. Logged. Don't retract. Okay. So guys, first instruction must be fetched. How? PC2 instruction fetch PC2 MAR, then PC incremented appropriately, so I am not counting it. Read from memory and place in MDR and copy that to IR. This is what instruction fetch. So a PC2 MAR and read. So this should happen first. Then that obtained one is in MDR by default. That you copy in IR. Now decode happens. Now register read. Because the operands are registers, I don't say operand fetch, I say register read. So how do you read the registers? If you look at the data path, first operand is through temp1, second operand is direct to ALU. Look at the data path. First operand is through temp1, second operand is through direct, and the output is coming through temp2. So First operand I am keeping in temp1. Second operand I send directly R2. Then first operand I am sending through temp1, add, and where the result comes in temp2. Then write the result in R0. So this should be the sequence. So 4, 1, 3, 5, 2. Do we have it? 4, 1, 3, 5, 2. Okay, I think this should be a 5, 2. I think I only framed option wrong. Okay, wait. Let me update it just now. This should be 5, 2, I think. Okay. So I only have did that typing mistake. So the answer is 4, 1, 3, 5, 2 for this sequence. Clear? Question number 33. A microcontrol unit having control word in the following format. If it has to generate 46 control signals, next address are selected based on 8 conditional oblique flag information. If the control memory is having 1024 control program of size 8 words, what is the size of control word in horizontal microprogramming? This is the control word format. So what is the size of this control word? We have to find out. Yes, please. Sixty-two bits, in bits of course. It is horizontal, guys. Horizontal means n control signals, n bits. So 46 control signals means 46 bits for the control field information. For this 46 bits. And next address, given the memory is having 1024 words. 1024 words in memory. So 10 bits for the next address. And we have 8 conditional flag information. So 8 conditions, so 3 bits. Total we have 8 conditional flags. That's why 3 bits. So total is 59 bits. That is the size of control word. Okay, Saubhagya Nayak and all the others. Chalo. Next address, why 13 bits beta? That next address is selected based on 8 conditional flags. I understand. 1024 control program of size 8 words. That means 1024 words we have. One minute. 1024 control words. No. 8 control words we have. No, Saubhagya Naik. 8 such control words we have. Control word memory. Control memory. This is the control memory. We have such control words. 8 control words. These are the 8 control words. These are 1024 operand words. This is different, that is different. Memory size is 1024 words. 1024 8 control words. Every control word is having 1024 words in it. That address. Okay? As a next address field. Next. Guys, for this I will hide myself. A CPU has only 3 instructions I1, I2 and I3 which use the following signals in time steps T1 to T5. Which of the following logic functions will generate the hardwired control signal for the signal A in? Saubhagya Naik, we are calculating the control word size only, 59 bits. Memory can hold 8 such control words. That is what it means to say. And in that every such control word, 1024 operand words you can have. Okay. See, where A in is there, please identify. Here, here, here Now, if you observe, during time T3, for all the instructions I have I1 plus I2 plus I3, right? Plus during time T1, I have for I1, during time T2 and T4, I have for I3. So, when it is for all the instructions, I can simplify it as just T3 plus T1 into I1 plus T2 into I3 plus T4 into I3. So, it is option A. Am I clear? Okay. Chalo, we will switch to the last topic of the day, I/O interfacing. Okay. Here is the first question. On receiving an interrupt from an I/O device, the CPU options halts for a predetermined time, hands over control of address bus and data bus to the interrupting device, branches off the interrupt service routine immediately, branches of the interrupt service routine after completion of current instruction. Yeah. After completion of the current instruction execution, branches to ISR. Because by default, we take interrupts as maskable interrupts. Unless we know its priority or it is given in the question, default interrupts are taken as maskable. So, after completion of current instruction execution, ISR is taken. Okay, chalo. Question number 36. A computer has a bus with 5 nanosecond cycle time, during which it can read or write a 32-bit word from memory. The computer has an Ultra 4 SCSI disk, uses the bus and runs at 160 megabytes per second. The CPU normally fetches and executes 132-bit instruction every nanosecond. How much does the disk slow down the CPU in percentage? Yes. Chalo, let me solve. It is given computer has the bus with 5 nanosecond cycle time during which it can read 4 byte word from memory. Right? Means CPU can read or write 4 bytes in 5 nanosecond time. In 5 nanosecond time, CPU can read or write 4 bytes. Read or write means transfer only, here or there. Okay. Now we have got a disk. This disk can read or write means transfer 160 megabytes in 1 second. Okay. It is not CPU, guys. It is bus. Bus can read or write 4 bytes in 5 nanosecond time. That is okay. 160 megabytes the disk can transfer in 1 second. Right? That means please, some spark will come when you compare these two. Once this is the disk capacity, disk bus capacity. So when you compare 160 megabytes at 4 bytes speed, how many nanoseconds time you want? If you use that bus, 200 mega, for simple calculation, let us take it as 10 power 6. I know it is 2 power 20, but let us take 10 power 6 into 10 power minus 9. This is 2 into 10 power 8 into 10 power minus 9. 0.2 seconds it takes. If you can use that bus, 0.2 seconds it takes. CPU in 1 nanosecond, it can fetch and execute 4 bytes. CPU 4 bytes to fetch and execute, it takes 1 nanosecond. Isn't it? But we have 160 megabytes that it take 1 second time. So this way you compare, it is 160 into 10 power 6 by 4 into 10 power 9. 4 into 10 power 7 into 10 power minus 9. This is 0.04 isn't it? This is nanosecond. Okay, fine, Saubhagya Naik. So when you multiply with 100, basically 40% slow down. Disk slow down the CPU by 40%. Okay. Chalo. Sorry. How it is 40%? 100 by 4. Actually, sorry guys, it is 25%. I mean 0.04 into 100, it is 4, right? 4 or 25% or 40%? 1 minute. CPU to transfer 160 megabyte, it require 1 minute. Let us calculate in the nanoseconds, then it would be clear. Four into 10 power 7 nanoseconds time it requires. CPU takes. So disk is taking 1 second. That means 10 power 9 seconds. So 10 power 9 seconds, 10 power 9 nanoseconds disk is taking. 160, 10 power 9 nanoseconds disk is taking. CPU is taking 4 into 10 power 7 nanoseconds time. So the slowdown 4 into 10 power 7 by 10 power 9 into 100. I can say it as 40%. Yeah, 40% guys. Okay. Question number 37. There are 4 devices. Guys, you watch it again so that you will get it clear. Don't worry. There are 4 devices of priorities 0, 1, 2 and 3. 3 has the lowest priority. Assume that each device routine has an execution time of 10 milliseconds. Every device has execution time of 10 milliseconds. The processor architecture provides for in-between diversion to high priority ISR. However, device 2 service routine has disabled. Device 2 service routine has disabled interrupts at the beginning and enabled interrupts just before the return. What is the maximum period in which device 2 will get the highest priority status? ये तो डायरेक्ट क्वेश्चन है, सिंपल क्वेश्चन है. Guys, device 2 disabled interrupt at the beginning of its execution, right? Disable interrupt, execution started. How long it execute? For 10 milliseconds. Just before the end of execution, enable interrupt. So during this time, that a device only can be with the CPU because no other device can interrupt. So what is the duration during which this device 2 got the highest priority? 10 milliseconds. Okay. One second. While device 2 is getting executed, device 3 definitely can't. Yeah, 10 milliseconds. Even if device 3 gets interrupted, device 2 will only have 10 milliseconds high priority status. Yeah, not 20. Now, question number 38. A computer consists of CPU and I/O device D connected to the main memory M via one word shared bus. The CPU can execute maximum of 10 power 5 instructions in 1 second. An average instruction requires 5 machine cycles, 3 of which use the memory bus. A memory read or write operation uses 1 machine cycle. Suppose that CPU is continuously executing a background program that requires 95% of its instruction execution rate, but no I/O instructions. If programmed I/O is used, and each one word I/O transfer requires the CPU to execute 2 instructions, estimate the maximum I/O transfer rate possible. एक क्वेश्चन समझने के लिए आपको थोड़ा टाइम लगेगा. CPU can execute 10 power 5 instructions in 1 second. So मैं directly explain कर रहा हूं, सुनो. 10 raised to 5 instructions CPU can execute in 1 second. Okay? And it is given 95% of CPU time is with no I/O. That means for I/O, how much time is given? 5% of CPU time for I/O operations. That means 5 by 100 into 10 power 5 instructions only it can execute. So this is 5000 instructions it can execute, and given one word I/O means 2 instructions. So 5000 instructions, one word I/O means 2 instructions. 5000 instructions means how many words? 2500 words per second. That is the answer. Got it? आप भी solve कर सकते शायद. You also could have solved it, but you require little more time to understand this question. I want transfer rate, not the time. That's why if every an average instruction require 5 machine cycles, you might be wondered, sir, why you did not count that? Because I don't want time. I am calculating the transfer rate here. That's why I did not count it. Okay. Next question. The size of the data count register of a DMA controller is 16 bits. The processor needs to transfer a file of 29,154 kilobytes from disk to main memory. Memory is byte addressable. Okay. The minimum number of times DMA controller need to get the control of the system bus from the processor to transfer the file from disk to main memory. Given data count register size is 16 bits. That means 2 raised to 16 bytes can be transferred in one attempt. Two raised to 16 means I can write it as 2 power 4 into 2 power 10 bytes. That is 2 power 6 into 2 power 10 bytes. That is 64 kilobytes. So in one attempt 64 kilobytes you can transfer. So for 29,154 kilobytes, number of attempts required is 29,154 by 64. That is, you can use calculator. 29,154 divided by 64. 455.53125. That means 455 times also you get bus, still the file, still something will be remained. So 456 times you require. Okay. So the answer is 456. Now, last question of the day. A device with a data transfer rate 10 kilobyte per second is connected to CPU. Data transferred byte-wise. Let the interrupt overhead be 4 microseconds. The byte transfer time between register and CPU or memory is negligible. Okay. What is the minimum performance gain of operating the device under interrupt mode over program controlled mode? Do it quickly. Prasenjit, Aryan and the others. Okay. In the programmed control mode, program controlled IO mode, 1 kilobyte you can transfer in 1 second. Sorry, 10 kilobytes you can transfer in 1 second. That means 1 byte can be transferred in 1 by 10k. That is 1 by 10 power 4. That is 100 microseconds I can write. But interrupt driven mode for the same require 4 microseconds. So the performance gain 100 by 4, 25%. Got it? Yes, Prasenjit, correct, 25%. Superb. That's all for today's marathon. May I know your score today? What is the score you got out of 40? Aryan, I think you were there since beginning. So how many marks you got, Aryan, today? And the others? (23). Prasenjit, 24. Good, good. So, work on the weak areas, learn where you are weak at, try to revise those concepts, those model questions. Okay, make sure the same mistake you are not repeating. Okay, that's all. This is my Telegram group link. If you have not joined yet, please do join and please do share with your friends this group so that all the others can join. I am sharing the PDFs of these marathons in the Telegram group. Also, you can ask your doubts. You can connect with your friends through this group. Okay? Yeah, Aryan, that's what. But identify your weak areas and work on it. Definitely you would do better in the actual exam. See you tomorrow morning at 10 a.m. with part 2 COA. I wish you all a very happy learning. Do like the session, share and subscribe to our BYJU'S Exam Prep channel. See you guys tomorrow 10 a.m. morning. Till then, have a great time. Take care. Good night everyone. Bye-bye. Thank you guys.